What's going on, y'all? Sean and MathSwap Tutoring here. Zero, one, or infinitely many solutions. What in the world does this mean? Typically, people encounter this topic in Algebra 1 when you start talking about systems of two equations. And here's the deal. What you're tasked with is how do I know if a system of equations, of two equations, has zero solutions, one solution, or what they call infinitely many solutions. Okay, so I want to break this down, hopefully in a way that'll help you to understand a bit more what's going on. It's not it it sounds a little weird, but it's not nearly as challenging as it might seem. So the first thing that I want to talk about, because I don't want to take anything for granted, is what in the world is a solution. So when you talk about a solution to a system of equations, all a solution is, it is an xy, an xy pair, a coordinate pair that makes both equations true. Okay? So we'll go in more in depth, of course, a little later, but if you look at these equations here, a solution to this system of equations, this system of two equations, is some xy that you could plug into this first equation, and it would make this equal to -5. Basically, a solution just makes the both sides of an equation equal to each other the way the equal sign says that they are. That's all a solution is. But a solution to a system of equations is going to make this first equation true. It's also going to make this second equation true as well, the exact same xy pair, the exact same one, okay? So it makes an equation true. It means that if it says it equals, it actually does equal. The left side equals the right side. Okay. Now let's keep on going. I just didn't want to take that for granted. Now, what does it mean? And we're just gonna do a verbal definition, a word definition. I mean, if it's zero solutions to a system of equations, that means there's no xy that solves both equations. And I just abbreviate equations. Okay. If we say there's one solution, that means exactly one xy solves both equations. And then if we're talking infinitely many solutions, what that means is that there is no xy that you can plug in that won't solve both. So I just say everything solves, so to speak. Or I say every xy solves both equations. Okay. Now, I have three systems of equations here. Here's one, here's another one, here's another one. Okay. And I'm going to go ahead and tell you this first system has zero solutions. This second solution has, I mean, the second system has one solution. This third system has infinitely many solutions. Now, here's where I'm going to really break down what's what. The way that you know that a system has zero solutions when you look at it is that you get what you call an impossible situation. This is what I like to call it. You get a situation where things don't equal, that you have an equation that is not true. Okay. So, what you want to do is you want to start solving this system of equations. So, I'm going to solve, or at least I'm going to begin solving this system of equations using substitution. So, let's take -2x plus y equals 5, -5. We're going to solve it for y. Y is the easiest one to solve for because it has no coefficient. Add 2x to both sides. So y is equal to 2x minus 5. Okay. Now we're going to sub this in for y in the second equation. So there you have, let's put a little line here, 10x minus 5y, but in place of y, we're going to put 2x minus 5 equals 15. Okay. Distribute, so you have 10x minus 10x plus 25 equals 15. And so you should probably see the impossibility here. Because what happens is when you sub in y into the second equation, you should be able to find x. But what happens is the x goes away. There's your sign there. This is the red flag here. That helps you to know there are no solutions because that whole variable goes away. And then you get the impossible situation, which is 25 equals 15. Never true. Zero solutions. Easy to see. All right. Now let's go to the next one. Whenever you have a system that has exactly one solution, what happens is you should be able to find, if you find an exact value, exact value for one variable. In other words, if you get an exact value for x or y, it doesn't matter which one, then you know your system has only one solution. Okay. All right. So let's take this second system. I'm going to solve it for x. So x is going to be equal to 1 minus y. Now we're going to substitute that in for x in the second equation. So that's negative 2x, but x is 1 minus y, plus y equals negative 5. So then you have negative 2 plus 2y plus y equals negative 5. Let's add 2 to both sides. So 2y plus y, that's 3y equals negative 3. You see that? So we get y equals negative 1. Bingo. We got exactly one value for one of the variables. We don't have to go any further to know that there's one solution. Period. Okay? Now, the third situation, infinitely many solutions. The way that we know this is the case is by this. The equations are the same. So the two equations that are part of the system, the way that I know that it's infinitely many solutions is that the equations are exactly the same. Okay? Now, so if you look at this system of equations, I'm gonna prove it to you by look at this one. You see how each of these has a factor of 2 that can be factored out? Okay? And so I'm gonna divide this whole thing. Actually, specifically, I'm gonna divide the whole thing by negative 2, just to kind of manipulate it to show you that it's gonna be the exact same thing as this. So 4x divided by, I'm sorry, negative 2. That's going to be negative 2x. Negative 2y divided by negative 2 is going to be plus y, and then 10 divided by negative 2 is negative 5. So you see, these equations are exactly the same. Okay? Now, let me do this, because this is one of the ways that people talk about a lot already, but I'm going to help you to understand this. Okay? If you look at a system of that has zero equations. Check this out. Let me use a different color here. When I solve this equation for y equals 2x minus 5. Okay? Now, if you look at this, let's solve this one for y as well. So that becomes, let's see. And I'm going to actually erase my work here. No, I'm not. I'll keep it up here. So you have that's going to be negative 5y equals negative 10x um, plus 15. You divide the whole thing by negative 5. And so then you have y equals, let's see, 10. Is that how I want to do this? Let me see. Negative 5y equals negative 10x plus 15. Okay, yes. And then that y equals um 2x um minus 3. Look at these. Y equals 2x minus 5, y equals 2x minus 3. So what you have is the same slope. So same slope, but different y-intercept means zero solutions. Why is that? Because if you were to graph these, and I'm not going to try to graph now, but it's like an upward line that's kind of like this. Basically, these lines will look something like this. Parallel lines going in the same direction, but they graphically, you see they never will touch. So that's important to understand. That's what happens graphically if you have zero solutions. A second way of being able to tell that. If there is one solution, the way that this will look graphically, and I'll show you, I guess I can kind of, well, I won't show you by manipulating these, but basically what happens is this one, let me see, this equation is y equals negative x plus 1, so it's going to look something like this. And then this one is going to be y equals positive 2x minus 5. So at some point, that graph is going to go up. Graphically, they're going to touch at one point, and it's going to be that exact x and y that you find. Okay? So intersect. They intersect. Be consistent. Oops, I tried to choose green. That's okay. And then finally, with this third example, what you have is you have a line. For example, this would be maybe looking like this. And then when you graph the second one, because it's the exact same thing, these lines would just lay right on top of each other. They're exactly the same at every single point. Okay? So it would just be, it just lay right on top of each other. I'm trying to see how to show that. But yeah. All right. So that's how you can tell whether you have zero, one, or infinitely many solutions. Hopefully, this helps you to get a better idea of what's going on with this so you can kind of like really understand what they're asking you. Let me know in the comments, okay? Now, if you came across this video and you're not a subscriber already, please subscribe, share it with a friend, and also I hope that you have a great day. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.